What is a holding pattern? Why do we have holding patterns? And which are the holding entries? By the end of this video, you will be able to answer all these questions. Hi there, I'm Gabriele from pilotclimb.com. I'm a trainer captain on the Boeing 737 and today I want to share with you what you have to know about holding patterns. So without further ado, let's jump right into it. As the name says, the holding patterns are procedures that allows the controllers and the pilots to make up time. The pilot might need, or the controller might need time for many reasons. The pilot might need time, for example, if he has some non-normal situation on board and is reading the Q range or is reading some manual or is taking some information before taking a decision. For weather, for example, if you cannot land because the weather is too bad, you can join a holding pattern to wait for the weather to improve. For the controller side, if he has too many aircraft landing in his airport, he might use the holding pattern for traffic separations and traffic flow management. So as you can see, the holding patterns are very important when flying an IFR. But these holding patterns are not procedures that every pilot does as he wants. The holding patterns are very structured and they are very precise, and they are available on the charts. You can find the holding patterns on the airways and the cruise. You can find them during the arrival phase, also called star, and you can find them during the approach phase, also called approach phase. So if you don't know what the star or the approach charts, the approach procedures are, I made a separate video where I analyze these procedures. I strongly recommend you to go there and watch them. But anyway, as we said, the holding patterns are inside these procedures, and because they are very well structured, the pilot, when he needs to hold somewhere, he will find out that the holding is over a fix. So in order to understand how to read an holding pattern, we're gonna talk about the holding structure. Let's jump into it. So as you can see, if you look at the whiteboard here, every holding pattern, the first most important thing to understand is that every holding pattern has got a fix of reference, okay? This is a fix where the whole holding pattern is built up around. A standard holding pattern is a right turn holding pattern, okay, standard one, and non-standard is a left turn holding pattern. This has got the outbound turn and has got the outbound, and then the holding pattern has got an inbound turn, like that, and then has got an inbound segment, okay? So in this case, if this is the north, okay, this is north, sorry for my drawing, I know it's not perfect, but I'm doing my best, has got, this is the outbound, and this is the inbound turn, and this is the inbound. In this case, the inbound will be 090, because if this is north, this is 090, okay? This normally, the holdings, they are time holdings. So this outbound is normally 1 minute, okay? But you can find as well holding patterns that are not made by time, but are made by distance. So the holding pattern, for example, if you take this holding pattern, instead of making with time, we make it with distances. We can say that the distance from here to there, okay, it's 5 nautical miles. Okay, so we know that this segment is 5 nautical miles long. So as you can see, the holding patterns can be built as a time or as a distance, okay? First thing to know is that below flight level 140, so below flight level 140, the timed holding has got an outbound of 1 minute, but above flight level 140, this outbound time or this inbound time is 1 minute and 30 seconds. Okay, so we know already that depending on the altitude of the holding, we have a different time to respect, okay? So then as well, the holding patterns, they have as well a minimum holding altitude. So minimum holding altitude you found in the chart is written like this, MHA, which could be 6,000. That means that you cannot join at the altitude below 6,000 feet. We'll see some examples in the actual chart in a second, okay? Then as well, the holding pattern has got a speed speed limits, okay? The speed limit, speed restrictions, okay? So what happens, this speed limit that I'm going to show you, they are in accordance to the current conditions shown in the CAO doc 8168. It's a document where all this 8168 doc is a document where all the laws about IFR are written down, okay? These speed limits applies to the document, and normally is the speed limits that everybody uses, okay? So the speed limits are from 0 to flight level 140, okay? The maximum speed you can fly and holding is 230 knots, okay? From flight level 140 to flight level 200, the maximum speed you can use is 240 knots. From flight level 200 to flight level 340, the maximum speed is 265 knots. And from flight level 340 or above, the maximum speed will be Mach 0.83. Okay? So these are speed limits in normal conditions. What I want to show you is that we've got as well speed limits in turbulence condition, okay? Speed limit when we have turbulence, because the aircraft when it's in turbulence should fly the best penetrating speed that, depending on the aircraft, has got this speed. The best penetrating speed is a speed that the aircraft has got the best turbulence resistance capability, and this speed should be 200 knots always, all the way down to flight level 340, okay, or Mach 0.80. So which one of these is the lowest speed, you should use that speed, okay? So from flight level, from ground all the way down to flight level 340, this is the speed you should use when you are in turbulence. So inside a turbulence, when you are turbulent air and you're inside a holding up to flight level 340, you use speed 280 knots or Mach 0.80, whichever is slower, okay? Then above flight level 340, okay, we've got Mach 0.83, and as you can see here is the same as this one, okay? So it is important to understand that these are maximum speed, so you can fly below. But for any reason, if you need to fly above this speed, that doesn't mean that you cannot fly them. The important thing is that you talk to the ATC, to the controller, okay? Let's say now you are a small airplane, so category Alpha Bravo airplane. If you don't know what the category Alpha Bravo for an aircraft is, I made a separate video called Aircraft Approach Categories, where I go through the categories and explain what it is. So if you have an aircraft on the category Alpha and Bravo, the speeds, the maximum speed in the holding changes a little bit. So for category Alpha and Bravo, the maximum speed from 0 to flight level 140 will be 170 knots, and that's it basically. This is the only restriction that is different compared to the normal from category Charlie Delta Net. Alright, so I hope the speed restrictions are clear now, so we can move on. The next thing that I want to show you is where are these holding patterns located in the arrival chart or in the approach chart, and how to read these. So without further ado, let's jump into it. So this is a chart of the Madrid airport, okay? It's a Jepsen chart. Is most probably is out of date because it's quite old, but that doesn't really matter since we are talking about the holdings, and the holdings are always the same. So what we can see here is that in the chart, I'm gonna highlight the holding. Okay, this is one holding here, as you can see in there, it's depicted. This is another holding here, okay, and this is another holding here, okay. So as you can see here, we've got 3 holdings along these arrivals, and let's see what these holdings are all about. Okay, so the first holding, for example, we can take this holding over Tobec. This is a star, okay? This chart is a star, an arrival. Again, if you don't know what is a star and how to read this chart, go and watch the video, but just stay focused on the holding patterns, okay? This chart has got an fix, which is called Tobec, okay? And we said that every holding pattern has got a fix as a reference, is a right turn, all right? So it's a right turn, as you can see here. It's a right turn, okay? Then has got a minimum holding altitude MHA of 5,000 feet, okay, and a maximum altitude of 9,000 feet, all right? So we can fly this holding here, the Tobec holding, between 5,000 feet and 9,000 feet. Okay, we have a precise airspace where you can fly this holding. Why is that? Because most probably we're gonna have aircraft that are above us, and below us we might have some terrain. That's why we've got these restrictions in altitudes. And this holding is between the distance 4.9 and 11 nautical miles. Okay, so what is it? Is that this distance here, as we discussed earlier, is a distance holding and has got from 4.9 to 11 nautical miles. The difference, this is a 6.1 nautical miles. So this segment here is a 6.1 nautical miles. Okay, so what you have to do is that, as you can see here, we've got this Papa Delta Tango is a VORDME. Okay, so what you have to do, since the Papa Delta Tango is here, what the holding is telling us is that this holdings is between the distance 4.9 and 11. So this is 4.9 nautical miles. This is the distance, okay? So this is the 4.9 nautical miles from Papa Delta Tango, and this is the 11 nautical miles. So when you see that you are on the radial, this radial here, inbound, Papa Delta Tango, and you are at distance 4.9 nautical miles, that means that you are over Tobec. So you turn right, okay, and once you are in the outbound, which is the opposite of the inbound, you fly until you read on your DME. Again, if you don't know what is the DME, I have made a separate video. Then when you read on your DME the 11 nautical miles distance, you turn right, you intercept the inbound, and then when you read 11, 10, 9, 8, 7, 6, 5, 4.9, again, you are over Tobec. That's how we read, and that's how we know that we are doing the correct procedure, all right? In this case here, let's analyze this procedure in here. For example, the Burex, we look at Burex, here we go. So Burex is here, all right? This is the point Burex. This is the fix of reference, okay? As you see here, we've got clearance limit Burex. That means that it's a very important holding, because if the controller doesn't clear you to continue beyond Burex, you have to join the holding. In this case, this holding has got a right turn, so as we can see here is a right turn, right? Has got a minimum holding altitude of 12,000 feet, and we've got another minimum holding altitude of 10,000 feet, but we have this one here, we're gonna read that in a second, what does it mean, and a maximum flight level 240. Okay, 240. This is the maximum flight level that you can fly, and is another distance. It's another distance holding, because it goes between 3.8 and 47 nautical miles. Papa Delta Tango DME. So this is how much is it? 9 nautical miles holding. Okay, so the distance between here and there is 9 nautical miles. So it's not a timed holding. And so what happens is that if you arrive here with your aircraft along here, and then at Burex the controller doesn't tell you to continue, doesn't tell you anything, doesn't clear you to continue, you have to turn right and do this holding. Okay, so this holding has got an inbound of 0.48, as you can see here, and you join the holding 9 nautical miles, right turn, and you join the holding until the controller actually tells you that you can continue after Burex. Then the last holding here has got a fix of Tango Lima Delta, Toledo, which is a very nice city in Spain, and has got a right turn, so another standard holding, sorry, and it has got an inbound of 131, as you can see here. This one is 131. Okay, it's telling us that has got an inbound there, and then it's got minimum holding altitudes. Again, 2 minimum holding altitudes. One is 12,000 feet, and the other is 10,000 feet, and then number 1. We're gonna read that in a second. The maximum holding altitude is flight level 240. The number 1, when you have these numbers here, 1 and 1, you have to look around the chart and find out where the number 1 is. And as you can see here, we've got this number 1 here, says minimum en route altitude, between bracket minimum holding altitude by ATC. That means that the ATC can clear you to join these holdings at 10,000 feet and not at 12,000 feet. But you need to be cleared by ATC. You cannot do it by yourself. All right. So we analyzed 3 types of holdings, and actually in the Toledo holding, I don't see any distances information about the outbound and the inbound. So that means that in this case, this is a 1 minute holding, okay, because it's below flight level 140. Because the minimum holding altitude is 12,000 feet. So if the minimum holding altitude would have been 15,000 feet, as discussed earlier, we should have been flying at the outbound should have been 1.5 minutes and not 1 minute. But because this minimum holding altitude is 12,000 feet, the outbound will be 1 minute. Now what I want to show you is the difference of some holding patterns in the approach chart, in approach phase, okay, the last phase of the flight before the landing. So let's go. Okay, as you can see here, we've got another approach chart. Okay, we've got another chart. First, we have got the arrival chart, the start that we just saw now. And now, once you arrive at a certain point, you have to join another approach in order, another procedure to land. Okay, and this procedure is called approach. If you don't know what is approach and how to read this chart, I made a separate video. I strongly recommend to watch that. And of course, I made another video where actually I fly one of these approaches in the simulator. So, but here again, we stay focused only on the holding pattern. As you can see here, we've got an holding pattern here, all right, and we've got an holding pattern here. As you can see, the color of this holding pattern here is slightly different than the standard holding pattern that we've seen. So far, we only saw holding patterns with this thin black line, but here we've got a bold black line. What is the difference? The difference is that this pattern here is a procedure in order to make you be established inbound for landing. Okay, it's not a holding that you have to join to take time, okay, because maybe you want to land and there is no space for you and so on. This is a procedure. This is still a procedure. So when you join over this, for example, from here, you fly over this, if you do this procedure there, and then you do like that, okay? So that is a different, this is a part of a procedure, and this holding is still part of procedure, but it's made to make up time, okay? But this is actually something that you have to fly. It's not made for time, but it's made for you in order to let you be established inbound, okay? So what we've got in here is got, in this case, the DZEV is the fix, okay, then is a right turn, has got an inbound 0 to 0, as you can read here, is a left turn, so in this case is a non-standard holding pattern, okay, and then has got this holding has got an outbound that finishes at 12 nautical miles alpha echo alpha, and it starts at 8 nautical miles alpha echo alpha. So this part here, the outbound and the inbound segment of the holding is 4 nautical miles. It's not a time, okay? The minimum holding altitude, even though in here we can talk about minimum holding procedure, you can start from 4,000, so you are over this about 4,000. And then once you are established in the 200 inbound at 12 nautical miles point, you can go down to 3,500 feet. Okay, so, but this is not really the same thing of holding to take time. Is a procedure that you use in order to be established inbound, because you fly over this, you go left, you go 12 nautical miles, you go left again, you get established, and then you land. Okay, that's the meaning of this procedure there. But in case of go around, you see, in case of go around, you have to continue straight ahead and fly to David Point, which is this point in there, and join this holding. Okay, so this holding in this case has got David as a fix. As you can see here, this small triangle is the reference fix, and then is a left turn, so another non-standard holding pattern. Okay, has got an inbound of 205, because the inbound is always the segment that goes inbound the fix of reference, and has got 3,000 feet as a minimum holding altitude. And again, this is a distance holding, because it goes from 10 nautical miles here, alpha echo alpha, and it goes all the way up to 14 nautical miles. So again, this space in here, we've got 4 nautical miles, okay? And the inbound track as well is the same, 4 nautical miles. That's fantastic. So we analyzed the holdings, what they are them, and I'll show you as well the holdings inside the procedures. But what about the holding entries? Because you cannot, let's say we've got an holding, let's draw an holding, okay? I'm gonna make a fix here, okay? And we call the fix pilot climb, okay? That's the name of the fix. Climb. Fantastic. So this north, all right? So let's make a right turn here. So standard holding pattern, the outbound, right turn again, and then the inbound, okay? So this is a standard pattern. So the aircraft flies over the pilot climb fix, turn right, goes into the outbound, and then turn right after 1 minute here, okay? it's a right turn again, and then flies again inbound, okay, and then so on. So if he wants to take time, he's gonna fly around his holding for as many times as he wants, as many times as he needs. But if the aircraft arrive from here, for example, all right, he cannot just do like that and then fly like that and then join. That doesn't work, because by the time he's gonna do the turn, it's gonna be here. By the time it's gonna be established on the outbound, it's gonna be here. And then if he turns, it's not gonna follow the holding pattern. And the problem with that is that around the holding we might have some terrain, and the holding are made clear of terrain. So we need to make sure that we are within an area around the holding that is actually clear of terrain. So we need to stay as close as possible to the actual holding pattern route, okay, holding pattern procedure. What happens is that the authorities made these holding patterns. The holding pattern, we've got one holding pattern entry is the direct one, okay, the direct one. The second one is a parallel entry. We're gonna talk about that in a second, parallel. And the third one, it's teardrop entry. Okay, let's see what it is. Okay, what we have to do first of all, in order to understand which are the holding patterns, we have to divide this holding into 3 separate areas, because depending on the zone, on the area you arrive, on the sector you arrive, you have to either enter directly, enter using a parallel entry, or enter using a teardrop entry. The way we do it, and the best way to remember, is that you have to take the inbound, okay, and draw an imaginary line, okay. You draw this line here, okay. And then what you have to do, you take from the fix, you draw a line that goes outbound the fix of 70 degrees. All right. So what will happen is that then if you extend this part here, you're gonna have this angle here is the 110 degrees. All right, and then you're gonna have another segment here, which is 180 degrees, right? So depending on which sector you arrive, you have to use a direct, a parallel, or teardrop entry. If you arrive on this segment here, let's say segment A, you have to use a direct entry. If you arrive on the segment B, let's call it, okay, you have to use a teardrop entry. Okay, if you arrive on the segment C, you have to use the parallel entry. All right, so the way you can remember is the following. If you see on since the holding is like that, if you arrive on this area, it's very, it makes sense to join directly flying over the fix and then turn right, okay? Because let's say you arrive from here, this area, okay, from here, it doesn't make sense to arrive over the fix, then right turn and then join directly. You cannot do that, okay? If you arrive from here, you will do a parallel lane. So let's talk about if an aircraft arrives from the sector B. Okay, this is the aircraft that's arrived on the sector B. Sorry for my drawing again, it's the best I can do. And so if it's flying like that, what he has to do, he has to do a teardrop entry because the B there. And what will happen is that he has to overfly the fix, leave the fix with a 30 degrees difference between his teardrop outbound sector and the inbound, okay, for 1 minute, okay, for 1 minute. Then he has to do a right turn to intercept and follow the inbound. Then when he flies over the fix again, he can join the holding. Okay, so this part is all holding entries, and this is a teardrop. As you can see, the way you can use it to remember is that it looks like a tear. You see, a teardrop, you see, it's like the shape is like this one. Okay, so that's the way you can remember. So you arrive over the fix, you leave the outbound by 30 degrees of difference for 1 minute. Then once the 1 minute is over, you turn right and then you join the holding. Okay. Now let's talk about if an aircraft arrives from the sector Charlie, okay, the sector C, so is this one. So it's coming like that. What he has to do is has to overfly again the fix. Then he has to go parallel, and that's why it's called parallel to the inbound, but in the opposite direction for 1 minute. Then he has to turn left and fly over the fix. Then once it flies over the fix, it can finally join the holding pattern. Okay, my suggestion is do this in quite tight way, because you don't want to do something like that. Okay, take your time, and then maybe you will never fly over the fix, and then the fix is behind you. Okay, so my suggestion is do a nice correction. In order, what I do normally, once I read 1 minute here, I turn left quite sharply to join the inbound already. Okay, making sure that you join you overfly the fix. Okay, because what I see, what happens a few times is that after the 1 minute you do a not very good turn, and then you arrive in here. Okay, it's kind of, you don't overfly the fix, and then your holding pattern is suddenly not correct, because then you have the fix at the back and you cannot take the reference when to start the turn. Okay, so depending on your sector, again, you have to do a different type of holding entry. As you can see now, it makes sense, because if you arrive from here, it makes sense to go and do something like that. If you arrive from here, it makes sense to arrive and do something like that. Okay, the parallel entry. And if you arrive from this sector here, it makes sense to join directly. Okay, one thing to remember is that all the turn has to need to be done with a 25 degrees of bank, or a 3 degrees per second turn. So that means that a 3 degrees per second turn means that every second you do a 3 degrees adding variation. So in order to do 180 degrees turn, if you do 3 degrees per second, it's going to take 1 minute for you to do the turn. So the holding will be 1 minute on the outbound turn, 1 minute on the outbound, 1 minute on the inbound turn, and 1 minute on the inbound. So it's going to be a 4-minute total time for the holding. I hope the video was clear for you and you took something out of it. If you like it, give it a like and subscribe to the channel to support me. And go in pilotclimb.com, check the website where you can subscribe for free pilot training content. And I'll see you in the next one.